Hello everyone. Because in the last class many people were absent, I'm just trying to record this particular session which we had done on supply chain contracts. So generally when we talk about any relationship between buyer and supplier, one of the things that we talk about is this concept of supply chain contracts. And contracts are largely used for managing any kind of opportunistic behavior that is shown by either the buyer or the supplier, right? So that is generally the reason why we have supply chain contracts. Now, one of the key aspects of the supply chain contracts is that you talk about the price and the quantity that is being delivered. There are other main elements which are related to supply chain contracts that we will discuss further. But largely, these are the two main things that we will look at. Now, to understand why supply chain contracts are important, we will take a particular context that we are all familiar with. That is the Newsvendor context, right? So all that we know about Newsvendor is from whatever we have discussed in operations management is that we know that it is for a perishable good, and we know that this is the optimum service level that we talk about here, where we say that optimum service level represents that the probability demand is less than or equal to Q star is equal to Cu divided by C plus Cu, where we talk about Cu as the cost of understocking and Co as the cost of overstocking. Right. So this is what we generally discuss as part of our Newsvendor formula. And optimum service level, we say this because this is the service level at which our entire profits are kind of maximized, right? So that is what we generally look at. Now, this is largely what we had looked at as part of our discussions in operations management. At best, we have said that if we know that P is the selling price and C is the cost price, cost of understocking is going to be P minus C, and cost of overstocking is going to be C minus V, where salvage value is V, the cost price is C, and selling price is. So this is what we have discussed. Now, from this particular thing, what we used to do is, if we know a particular distribution, we would say that based on that particular distribution, we will identify what is the corresponding Q star, which is the optimal stocking quantity, right? So that is what we will generally identify. Now, one of the things that we would also be interested to know is that if this particular person is stocking Q star, it does not mean that they are always going to fulfill all the demand and they will not be left with anything. Given that the demand is uncertain, one of the things that we will see is that either the news vendor will end up with excess inventory, or there might be a situation where the demand is more than the quantity stock, which will lead to what we call as lost sales. Now, for us to understand that, let's assume that the demand follows normal distribution. The demand follows normal distribution. And what we are saying over here is that this is the mean value. And let's say, for example, there is a standard deviation sigma. Then demand could be any particular value, which is over here, over here, over here, or over here, right? So these are the different values of demand. Now imagine you are stocking this particular quantity. Let's say this is your Q star. This you have identified using your optimal service level. Now, based on this optimal service level, if you have decided to stock this particular quantity, any demand value, let's say these are all different demand values, D1, D2, D3, D4, right? D4, this is the one that I'm referring to. D4, right? We can clearly see that any demand D1, D2, or D3 is going to be less than Q star, because this is like a number line where these values are between minus infinity and plus infinity. This is mean. So any demand value which is to the left of this Q star is going to be where I will, let's say, for example, this is the demand, right? D3 is the demand. So that means that I will sell because I have stocked Q star and Q star is greater than D3. I would sell all that is required. So that all the demand would have been met. And the leftover, which is Q star minus D3, is what will be my leftover inventory. On the other hand, if let's say, for example, the demand happens to be D4, right? So this particular thing, in this particular case, is going to be the leftover inventory. Right? This will happen when my demand is going to be D3. But if my demand is going to be D4, right? What will happen is the difference between these two. That is, here you can clearly see that D4 is greater than Q star because D4 is to the right side. On any number line, you will see that numbers go from lesser values to higher values on the number line, right? That is from left to right, the numbers only increase. So that means that if D4 is greater than Q star, D4 minus Q star here represent the amount of demand that you are not able to meet because Q star is the maximum that you have stopped. So you will only sell Q star. So D4 minus Q star is nothing but your lost sale because you are not able to meet that demand. Now, given that the demand follows mu and sigma as standard deviation, if let's say the demand is following this particular distribution, and if we are interested to identify if I am going to start Q star, what are the chances that I will end up with the leftover inventory? What are the chances that I will end up with a lost sale? How much would that expected value be? Is of some interest to me to try to understand whether I should stock more or stock less. Right. So that is the reason why we are first understanding this. Now, based on this particular thing, as we go forward, as what we have discussed in the Hamptonshire case, you will understand that the metrics that we are calculating over here are going to be useful for us to explain why these supply chain contracts are useful. Okay. So let's start with trying to understand what is this concept of. So we will try to look at different metrics. These different metrics are expected leftover inventory, is expected line. We'll also look at expected lost sales less and expected sales your sales or your S and expected profit. We will look at all of this. So generally expected profit is represented as P of pi. Pi is the symbol that we generally use for profit. We'll understand more as we go forward why that is the case. And we'll also look at the fill rate. Mind you that fill rate is different than service level. When service level talks about the number of times you are able to fulfill the demand completely using your on-hand inventory, fill rate is about the percentage of the demand you are able to fulfill, percentage of the demand that you have got that you fulfill for from your on-hand inventory. Right? So we'll look at all of these things. So let's start with first with the expected loss sale. Right? Expected loss sale. Now, as we have understood, generally, when do we have loss sale? Loss sale is generally had when our demand happens to be more than our quantity that we have ordered, right? So expected loss sale is going to be equal to the demand minus Q star when demand is greater than Q star and is equal to 0 when demand is less than Q star. Right? Whenever my demand is greater than Q star, I will have an expected loss sale. And whenever the demand is less than or equal to Q star, the loss sale would be 0. Because if I have more stock than the demand, then there will be no loss sale. That is intuitive, right? Now, if you look at this particular thing, depending upon the distribution, remember that the demand is uncertain. That means that this many number of times, probability corresponding to this, you will have this much amount of loss sales, and this much amount of time, you will have a zero loss sale. That means that ideally, if demand distribution was discrete, right? Like for example, something like Poisson distribution or binomial distribution, expected loss sale would have been D minus Q star multiplied by probability of D greater than Q star plus 0 multiplied by probability demand less than or equal to Q star. Because as you know, expected value for a discrete distribution is nothing but the sum of sigma represents the sum over here, x into P of x. Right? So this is the expected values formula, and that is what we had used to arrive at this. Right? But because the demand distribution that we assume is normal distribution, which is normal distribution is continuous, what we are going to do is we are saying expected loss sale is going to be integral. Demand is going to be represented by the letter x because x is varying. Now, when do we have an stock out? Whenever the demand is greater than Q star. So while x can take any value between minus infinity and plus infinity, between minus infinity and plus infinity, we will have, so we can write it like this, right? For example, the right light is minus infinity to plus infinity, d minus q star into f of x dx. But the problem is, from minus infinity to q star, the value of this particular thing, d minus q star, as we have seen over here, this value is 0, right? Any value which is less than q star, this value is 0. That means this gets converted into x is equal to q star to infinity d minus q star into f of x dx. Now, if you want to compare this with this, you can see that this minus d minus q star is the same over here. And this probability demand greater than q star is what is f of x dx is basically representing. That's all that you need to understand. So basically what we are doing is, we are saying that give me a particular distribution, which is like this, right? I'm saying this is the distribution, this is the mu, this is the sigma. If you are ordering Q star, what is this? What is this? What is this? All these values corresponding to the probabilities of these values is what this expected loss sales are going to be. Right? So that's what we are going to get. Now, the good thing is, because this is a normal distribution, like we have done in continuous review, we are going to use certain formula which we can find in Excel to get these values. So expected loss sale can be calculated with this particular formula, which is called as sigma LZ, where LZ is what we call as the loss function. And sigma is, as you already know, this is the standard deviation. And LZ is a loss function which we can write as f of small z minus z into 1 minus capital F of z, which is L of z. Right? And this L of z, as you can see over here, this is called as loss function. We have already seen what this small f and capital F is. In any particular setup, whenever we are talking about this, whenever we have probability distributions, whenever we have random variables, always remember that small f represents probability density function, and capital F is always going to represent cumulative distribution function. Yes, this is PDF and this CDF, right? PDF is like the probability at a particular point, while capital F is the sum of probabilities of all the values till that particular point. So in some sense, if you want to look at this in the normal distribution, f of x is going to be what is the height at this particular point, and which is small f of x, and capital F of x is going to be all the area to the left of this, right? So this is what capital F of x is going to be. So that's what these values are represented. Now, once we have the z value, remember z value is nothing but x minus z, if you remember from your statistics, is x minus mu by sigma. Here our x is nothing but q star minus mu by sigma. Now you might have a different x, but here we are looking at all the values corresponding to the q star, and that's what we did. Now once we have z, we can calculate capital F of z, small f of z, the z is there, sigma is there, so expected loss sales can be calculated. Right, so this is the formula for this. So this is expected loss sale. Now let's go to expected leftover. Expected leftover inventory is your LI, again is exactly opposite to the concept of your expected loss sale. Now we know that expected leftover inventory will only happen when your demand is less than your quantity ordered. So as long as demand is less than Q star, you will have a leftover inventory, and the moment demand is greater than or equal to Q star, you will not have any leftover inventory. Now, same way, if your demand is discrete in nature, this will be Q star minus B multiplied by the probability of D less than Q star plus 0 into D greater than or equal to Q star, that is probability of that. But because we are following demand is normally distributed, what we are going to do is that we are going to say that our expected leftover inventory is going to be integral of x is equal to 0 to Q star, 0 to Q star minus x into f of x. Yes. Right? Use the same logic that we have used earlier to get this particular thing. Now, if you expand this, when we try to kind of do this particular thing, integral 0 to Q star of x f of x. X and Q star is basically Q star, you will get this particular thing as Q star minus expected sales. Expected sales is basically whatever is that you are selling up to Q star is the sales, right? So that is what expected sales are. Now, there is another equation, and we discussed this particular thing in the class, that generally mean represents the amount of sales and amount of lost sales, right? So you can either have sales or lost sales, and around that particular spectrum, if you take an average of all of that, you'll get mean. So that's the reason why you have this equation, expected sales plus expected lost sales is equal to mean. Now, given that expected leftover inventory is Q star minus is expected sales, if I substitute the above equation in this, you will get expected leftover inventory as Q star minus mu plus expected loss sales, right? So this is for the formulas that we have. Then this is another formula that we have. L of Z is already a formula which we're going to use all of these in our equations and then this. Right? So this answers the metrics related to expected sales, expected lost sales, expected leftover inventory, and we have to now calculate expected, how to look at expected profit and bill. Right? Let's try to look at that. Now, if we look at expected profit, expected profit is nothing but what is the margin that this particular news vendor is making. The news vendor is making a margin of E minus C, and how much is this particular person selling, which is per profit, which is going to be expected sales. Now, once this is done, what is left over with him is expected leftover. Now, remember that lost sales will not get into your profit because lost sale is a lost sale. It is not, it's a, it's kind of an accounting term, but it is not exactly profit, right? So expected leftover inventory is something that you will have, which will be on your books. So you will have a cost corresponding to that. But if you can salvage that, you will get some money back, right? So that is the reason why this gets multiplied by C minus B. Now, as we already know, E minus C is your so P minus C is your cost of understocking, and C minus O is cost of overstock. So this is the formula for expected profit. This is what we will use again. And then you have your fill rate, which is another metric that we are going to use, which we are going to calculate as expected sales divided by unit. Okay. A couple of things that we need to notice over here is that we have expected formula for expected loss sales, expected leftover inventory, expected profit, fill rate, expected sales, and other things. If you look at this, one of the things that we discussed in the class is that expected sales less expected loss sales is equal to mean. Now, this kind of paints a picture that the amount of sales that we are making at max can be mu. That's not the way to look at this particular thing, because what we are representing is expected sales. That means sales could be more or less than mu, but once you multiply it with different probabilities of that particular thing happening, along with the loss sales and the corresponding probabilities, then they add up to the average value, which is mu. Right? So that's the way to look at it. It does not mean that you will only sell less than mu or at max mu. Right? So that's not the way to look at it. Remember that all of these are expected values. This is probabilistic. Right? Now, what we will do is we will try to look at an example and try to solve that particular thing using the data and the formulas that we have in Excel. And this is exactly what we had used to solve the Hampton-Shire Express. For those of you who were not able to attend that particular class, try to look at the solving the first 3 questions which are there in Hampton-Shire Express, which is largely based upon this particular concept, which is what we have done till now. We will apply this particular formula to build the different metrics of metrics for the Newsvendor, right? So let's try to do that. Okay. So, um, okay. So let's assume that in our particular setup, where we are saying that our selling price is let's say 30 rupees, cost price C is 20 rupees, and our salvage value uh, D is about 15 rupees. Okay. Now, let's say for example, mm, our demand is following normal distribution with mean, which is mu, which is going to be about, let's say, 200, and standard deviation sigma, which is about, let's say, 50. So this is the demand that is given. From here, we can calculate cost of understocking, the cost of overstocking, which is Cu and Co over here. And we're seeing that these values can be calculated as, before I do this, let me just introduce to this particular thing. Let's say this is P minus C, and this is C minus V. Right? So this is the cost of overstocking, cost of understocking, and we then have the optimal service level that we calculate, right? Which is basically the optimal service level, which we are representing using this, right? Which is CO divided by CO plus CO, that we are getting as CO divided by CO plus CO, right? Which is giving me, it is the optimal service level, right? So this is what is my optimal service level. Okay. Now, from this, what I can calculate is the Z value. Now, remember the Z value is Q star minus mu by sigma, but Q star is not yet identified. Right? So I can either identify Q star first and then calculate Z, or Z and then calculate this, right? Let's first calculate Q star first. So for example, let's calculate Q star. Okay. Q star, which is optimum quantity order. So optimum quantity order is always going to be based upon the optimum service level, right? So this is going to be norm dot inverse, always going to be norm dot inverse. This particular optimum service level is going to represent the probability, and the mean is given over here, the standard deviation. So if you use this formula, norm dot inverse, optimum service level, mean, and standard deviation, will get this optimum quantity order. So this is what is 221 that we got. Now from this, we can calculate Z. Now Z we already know is Q star minus mu by sigma. Let's try to calculate that. Now what I'm doing every time is that, for those of you who already know this, I'm trying to set the names to each of these particular values so that you understand when you look at the formula itself what is the formula that I've used. Right? So when typing this, instead of cell references, you are getting the names of it. This Q star minus mu by sigma. So Z gives me 0.43. So the other way that I could have calculated this is, say, once I have optimum service level, I could have also calculated this as the Z value, showing you another way over here, which is norm dot S dot inverse of probability is still going to be 0.43. So this is the same thing. The same that this is another way to calculate. Yeah. Now I have got Z value. Save this particular thing. Have everything that I required for us to calculate the rest of the things. Now let's start with expected loss save, or expected loss save. So expected loss sale, which is E of LS, we have said that is equal to sigma into L of Z. Yeah. Now sigma into L of Z, we have sigma into L of Z is something we can calculate only if we have the LZ values, right? Z is there, but we don't have LZ. And we know that L of Z function is something that we can calculate from Z. And L of Z is usually calculated as f of Z minus Z into 1 minus capital F of Z. Right? This is the formula that we have used. So I will try to get this from the Z value over here. All I have to do is use a function called norm dot dist. So what I'm going to do is norm dot dist. Instead of norm dot dist, I should rather use norm dot s dot dist, which is much easier because this is standardized normal distribution where I can just use Z value as the formula itself is showing me. So just select this Z value and say small f of Z is corresponding to probability density function. So I'll select the false value minus Z multiplied by 1 minus. Please don't use the square bracket like I've used over here because in the formula over there, because Excel does not understand square bracket, it only understands this semicircle kind of bracket. Another, sorry for not knowing the exact name of that. But it's dot test that this is L of Z. And once we have L of Z, that is L of Z with sigma values, and this is going to give us expected loss sales. So what we are saying here with the expected loss sale of 11 is that if the Newsvendor decides to carry a quantity of 221.5 with a mean demand of 200 and standard deviation of 50, given the other values of price, cost, and salvage value, there is a chance that this person will end up with 11 units of loss sale on average, right? So that's what this particular thing is saying. Now, once we have this expected loss sales, we know that we can calculate expected sales, which is much easier to calculate from this because we know that expected sales is expected lost sales is nothing but equal to 1. Right? That's what we know. So let's try to calculate that. Okay, so expected sales is mu minus loss, expected losses. As we have when expected losses are already calculated, mu is already something that I have. So what I will do is I will try to just, I will also do this so that you can see this. Yes. Yes. This is expected sale. So roughly I'm going to do a sale of about 189 units if I'm going to stock 221 units. That is what we are saying. Once I have expected sales, expected lost or leftover inventory is here because expected leftover inventory is nothing but Q star minus expected sales. So this is what we know. So I'm going to use expected sales value which I have over here. Let's say that the leftover inventory is Q star minus expected sales. So that is going to be 32. Now, generally thinking, you think about it, we say that loss sale is something that we have when my demand is more than the quantity that I order. And leftover inventory is when I have my demand less than the quantity that I ordered. So that means that you cannot have both leftover inventory and loss sale at the same time. But as you see over here, you have both leftover inventory and loss sale, which are positive. Please remember that these are expected values. These are not something that is happening at the same time. So what we are saying is, if your demand follows normal distribution between 200 and standard deviation 50, with the price 30, with cost 20, with P value 15, if you are stocking 221, which happens to be the optimal service level, then there is a chance that you might end up selling 188, or you might end up having 11 of loss sale, or you might have leftover inventory of 30, right? So that is basically what they are saying. Now, all of these are not going to happen at the same time. This is a probabilistic situation, right? Comparing all the situations which are happening, right? It's for you to resonate expected value. Think of this like I'm throwing a dice, and dice have 6 faces, 1 to 6. And if I ask you to calculate it, the expected value is 3.5, that does not mean that you are going to throw 3.5. Expected value for a dice is going to be 3.5 because it is 1/6 probability of getting any one of the faces 1 to 6, and if you just multiply 1 by 6 with 1, 2, 3, 4, 5, and 6, you'll get 3.5, but there is nothing like 3.5 which exists on the dice, right? So expected value is not the exact value that you're going to get, it is an average kind of thing. So that's what we are doing. All right, so this is what we are showing over here. Now we have expected loss sales, expected leftover inventory, all of this we have. The next thing that I can calculate is the expected profit. Profit, find nothing but calculated that as, let's do formula over here, equal to C into expected sales minus CO into expected leftover inventory. Correct this particular thing. Connected. Right. So this is going to be U multiplied by the sales minus CO multiplied by the leftover. So this is the profit that I'm making roughly. So given that I stock 221 units, there is a chance that I'll be able to make 17.7 dollars, whatever it is, the units that we are going to have for the prices. And the last metric that we are going to have is fill rate. The fill rate we calculate it as expected sales divided by, we have about 94% as the fill rate, while our service level is only 66%. Remember that we had discussed this, that in majority of the cases, the fill rate is always and always going to be greater than optimal service level. So these are the different metrics that we can calculate using the Newsvendor, and this is exactly what we have used in our Content Express case. Content Express case, if you have not attended the class, just go through that. First question is exactly this. You just have to change the values of VCV, right? And Just use this particular template. I'm going to post on Google Classroom now, along with the video. You can go through that and then take this particular template and build on that for the question number 1 in Camping Share Express. Question number 2 and 3 is something that we can discuss, which involves slight amount of changes. Once you have done that, that's where we're going into the concept of supply chain and then contracts. Tomorrow in the class, we will discuss about the supply chain contract part. We will try to see what exactly is the contract, what the different types of contracts, and based on that, we'll discuss further as to how contracts can help supply chains. All right. Thank you.